Okay, thanks. Thank you for being here. And first of all, I'm glad to be here. I mean, this is my first TED Summit. I remember being at TED Hack almost 10 years ago in Madrid, which was a fun experience. But this is different, so I'm really excited about it. And I'm going to talk about something that is quite new. So specifically about how WebRTC is trying to tackle the broadcasting world as well, which has historically been using very different technologies instead. So just a couple of words about me before we start. I got my PhD at the University of Naples, and as we established yesterday, I'm the only chairless chairman in a company called Meetcho, and I may be known as the main author of Janus. Just out of curiosity, how many of you actually already know about Janus? Okay, no, that's half the room more or less, so that's interesting. And these are a few links where you can get in touch with me if you want. There's some other information as well, including some ugly music that I like to write from time to time. And my company, it was born as an academic spin-off originally, because most of our team, me included, got our PhD working on real-time multimedia stuff. From a standardization perspective especially, we've been involved a lot in the ITF. And then we decided to create a company out of what we had been working. And that happened almost 15 years ago, and we do the usual things that you can expect from a small company like ours, so consulting services, commercial support, stuff like this, including support for some remote participation support to some big meetings like RIPE meetings, ITF meetings, and so on. And our base is somewhere around there, so definitely not the bad place to live in, as you can imagine. So coming to the meat of the presentation, so basically, as I mentioned, we wanted to check, me and other people wanted to check whether or not WebRTC could be a good fit for the broadcasting world. And first of all, it meant having a look at how traditional broadcasting works. And in general, you can assume something like this. So you have a source that is usually an application like OBS, for instance, using a protocol like RTMP to submit a processed audio and video stream to a streaming server. And then the streaming server takes care of distributing it to a larger CDN so that it can be distributed to a wider audience. That can be TVs, or it can be mobile phones or laptops or whatever, possibly involving some transcoding as well in order to provide adaptive streaming to those different devices, because of course a 4K screen has different requirements from a small mobile screen, for instance. And this works nicely. I mean, it has worked nicely for a very long time. The problem is that the moment that you want some more interactivity, this may not be enough. Because, for instance, if you think about betting, you're watching a football match somewhere, you want to bet on the football match, you cannot really do that if the match you're watching is 20 seconds behind. So that doesn't really work. You need something that is much closer to what's happening right now instead. During the pandemic, there was also something interesting happening where you had, since you couldn't go to a concert in person, there would be concert being played in custom locations, being recorded, being broadcasted, and then you had a whole wall of people connected from home that would attend the concert, just to give the artists some feedback that they were not just playing in front of a camera, but actually in front of real people. And of course, a scenario like this assumes that you do have a need for some sort of synchronization as well, because again, if the concert you're watching from home and you are one of the faces that are appearing on there, if the concert is 30 seconds behind what you're actually seeing, you may be dancing while they're switched to a very sad and slow song, and that doesn't really work. And of course, there's also scenarios like this, like those popular quiz applications that you can find on mobile phones. There's a person making questions in real time for an hour or so, and you have to answer before everybody else. This also requires you to have something that is as close to real time as possible, because while you could use a CDN, a regular CDN for that, the moment buffering kicks in or something else kicks in or there are delays, there are people that will be more advantaged than others, and that's something that you want to avoid. Which brings again to our point. So these are just a handful of use cases, but they already showcase the fact that we may have a need for something closer to real time instead. And why not WebRTC? I mean, WebRTC was indeed conceived originally for conversational audio, video, and data. So at the time, it was the attempt to fight the Skype domination of the conversation business. But we all know that WebRTC has been used for countless other use cases as well, which does include monodirectional streaming. You see a lot of webinars and stuff like this that make use of WebRTC. And the moment you use an SFU, like the one that we just saw in the presentation before, you're actually using WebRTC often in a monodirectional scenario because you're doing something one-to-many. Even in a video conference, you're actually having many one-to-many distributions rather than an actual conversational approach to how the peer connections are actually used. And for some weird reason, I mean, the broadcasting industry has been quite resistant to WebRTC in the first place. There was actually a bit of a fad that was documented by good old Dr. Alex a few years ago, where they basically provided some reasons why they didn't want WebRTC that didn't really make a lot of sense. Most importantly because we know that WebRTC, for instance, has good audio and video quality. I mean, there's a lot of features that WebRTC now supports that are actually quite useful in the broadcasting environment as well, because, for instance, Opus was a codec conceived for the internet, so it does really work pretty well there. It has some reliability features, including RAID redundancy or in-band forward error correction. It has built-in stereo support and even via multi-opus, which is a hidden feature that Chrome already supports. You can also do multi-channel with Opus, which is kind of cool. And with video as well, there are several different codecs that we have access to, and there's also interesting functionality like, again, simulcast or scalable video coding that allow you to provide that same level of adaptive streaming that may be needed in some cases in the broadcasting scenarios. At the end of the day, the real main obstacle has always been tooling, because we know that there's millions of broadcasters all around the world that use CDNs to broadcast their shows, or YouTubers or stuff like this. They all use applications like, for instance, OBS or others. They are used to these tools. And so if you want those users to start using a WebRTC-based infrastructure, you need to make it as easy as possible for them to just keep on using whatever they are comfortable with, and then just use a different technology to distribute it, which was really the main obstacle, and we'll see how this has partly been handled in a second. And if we look at this WebRTC broadcasting issue in terms of what do we need to do to make this happen, we can split it in two main blocks. The first one is ingestion. So how do we get something that has been produced, for instance, with a tool like OBS, to a server so that it can be distributed, and then how do we distribute it? So how do we send this WebRTC stream end-to-end to a lot of people? Which of course means that we should actually split this into three parts, because of course the scalability part may not be 100% related to this, because how you distribute it may be impacted by how you actually internally scale all of this for this to happen. And we'll address ingestion and distribution first, and then I'll spend a few words on how you could actually scale this as well. And within the ITF, a new working group was created called WISH to address exactly this use case. So how do we do some sort of WebRTC broadcasting? How do we use WebRTC for more than just conversations and stuff like this? And the main activity was working on a protocol called WIP, which made for this really interesting picture over there in a blog post some time ago. And actually this picture was something that we used in a blog post about 3 years ago, and this was before WISH actually existed as a working group. So Cosmos Software with Dr. Alex and Sergio had proposed this new protocol called WIP. So it was not an ITF protocol yet, but they had this idea and wanted to prototype it. And so we helped them prototype this on the server side. And then as soon as WIP became the first action item within the WISH working group, we started addressing these in another blog post that I encourage you to have a look at if you are curious about all these protocols. And if we have a look at it from a technical perspective, WIP is actually a quite simple protocol, because we all know that WebRTC itself can sometimes be a bit intimidating because it's a huge suite of many different protocols working with each other, but the signaling to make a WebRTC session happen doesn't need to be this complicated, which is the main aspect that we want to take into account when you have to integrate this into a tool like OBS, for instance. And as a matter of fact, WIP is very simple, because it's basically a very basic HTTP-based signaling protocol where you use an HTTP post to send your SDP offer, which is something that you need to initiate a WebRTC peer connection. You send your offer with the stuff that you want to send. You get an SDP answer from the server, and the negotiation phase is basically done like that. In a single HTTP transaction, we're already exchanged the two SDPs, which was cool. If we want to tear down the session, we can use an HTTP delete. So we are matching basically the HTTP primitives to some functionalities that we have, that we want to have. We can use bearer tokens, which are again an established technology in the HTTP ecosystem to do things like authorization. If we need trickle eyes, for example, exchanging candidates dynamically as we usually do in WebRTC applications, we can use HTTP patch requests. So again, very useful because we can just send small HTTP fragments to say, I have this new interface I want to use, and so on and so forth. And once you've done that, everything else is really just plain WebRTC. So if you are familiar with WebRTC in the first place, everything else works exactly the same way, eyes, DTLS, everything. And so from a sequence diagrams perspective, it's really easy to understand because you just send a post, you get an SDP answer back plus the address of the resource that you need to interact if you want to send candidates there. You exchange some candidates, the peer connection establishment happens. At the end of the day, what the really important part is you can start sending an RTP stream to a media server. And in that case, you see three different blocks over there, but this could be actually the same application, or you could distribute those blocks in different ways. It really doesn't matter. WIP is there just to make sure that you can use those HTTP exchanges to eventually create a peer connection to send something. And of course, I wanted to prototype this in Janus, which is a general purpose and open source WebRTC server that can be used for different things. And here are a few links if you want to give it a try. And basically, rather than embedding WIP inside Janus itself, because Janus does have its own API, I decided to just keep it simple. So create a very simple shim, a very simple intermediate application that implements the WIP API, which, as we've seen, is very basic. It's just a very basic web server that needs to handle some HTTP requests and take care of the translation to the Janus API on the back end. So anytime somebody wants to publish, we create a session to Janus, we create the resources to the video room plugin, which is the SFU plugin, so that we can create a participant in there. At the end, the result is that SDPs go back and forth between that client and Janus, and the peer connection is established. So done, very, very easy. And I created prototypes for both server and clients, because again, I mentioned how important it is for ingestion to be not only done via browser, but also via custom applications. And I wanted to prototype that via a GStreamer powered kind of application. And funnily enough, GStreamer does support WIP natively now, so my application is actually quite redundant, but it was quite useful in the beginning. And I mentioned that tooling is an important thing, and how many people, for instance, use OBS every day. And luckily, OBS now does have support for WebRTC, so it's not complete. There are some small issues here and there, but as you can see in that blog post over there by Chad Hart, Sean Dubois, we have to thank greatly for that, actually did implement WebRTC support in OBS, which means that if you download version 30 of OBS, which would be the latest, among the different streaming options that you have, which could be stream to Twitch, to YouTube, or whatever, there's also stream to your WIP server. So you provide the information to a WIP server and it should work. And I tested it with Janus and my simple WIP server, and it actually did work, because in that case, I was just opening the video room my WIP server was publishing to, and I could see the scene that I had created in OBS, which was really cool. So now we have ingested the stream, how do we distribute it? So how do we consume it? Because of course WIP is cool, but only allows you to ingest media. So we are just pushing media to a server. You don't use it also to receive media instead. And I mean, in practice, it's not a problem from a technical perspective, because distributing the stream is again just a matter of how do you use an SFU to distribute stuff. But of course, the problem is that each SFU has its own API, and we want to avoid this API fragmentation. We want a standard way to receive a stream, just as we have a standard way to ingest a stream with WIP. And that's something that Web covers. It's a new protocol that is part, again, of the same working group that I discussed before, that is called WISH. And if you're confused by all these acronyms, it's absolutely normal. I mean, and there's WIP, there's WEP, and for a little time there was also WAP, so it's not a typo, it existed. And if you want to learn more, you can have a look at that blog post that I created over there. And in a nutshell, basically, WEP is very much the twin protocol of WIP, and is almost like a clone to WIP, because WIP takes care of ingestion, it creates send-only peer connections. Web does the opposite, so it creates peer connections just to consume stuff, so receive-only peer connections. And the approach is very much the same too, because I think they just did a copy-paste and just replaced some words here and there to get things started. And as a matter of fact, you still use HTTP using the offer-answer approach, you still use bearer tokens, you still use HTTP patch and fragments for trickle, and WebRTC is used the same way as before. I have some concerns about how web is currently done, because at the moment it works exactly as WIP. So even if you want to watch something, you have to send an offer and receive an answer, which is kind of counterintuitive and not how most of the WebRTC servers actually do it, because when you want to subscribe to something, it's the server that knows how the media is done, and so it's typically the server that offers and you answer. And this would have allowed for WIP and web kind of interactions. So basically chaining WIP and web, it could have allowed for cool things like WebRTC federation between different implementations of WebRTC. It could have been cool, but instead it isn't. So I did document my rant a bit there, so I won't go too much in detail in here there. But I mean, web as it is right now does work if we exclude this limitation. And this sequence diagram looks pretty much exactly the same as the one that we've seen before, with the difference that all these dents over here will eventually lead to media going from the server to the subscriber, because in this case we are receiving media instead. And just as I did with WIP, I also prototyped web as well. So, and I did follow the same exact approach, so a very thin layer in front of Janus in order to translate those different languages, receiving media from the streaming plugin rather than the video room plugin, because the streaming plugin is the one that in Janus is most optimized to broadcast WebRTC media. And I created again client and servers, but the client is really not that interesting in the web use case, because with web it's much more interesting to use the web browser to actually receive media rather than a custom application. You don't use a custom application for that. Which brings us to the next point. So we've seen how we can ingest, we've seen how we can actually consume ingested media, but what if we don't want to just use a single server to do everything, which may help us maybe a few hundred subscriptions and so on? What if we want to stream to thousands or millions of people using WebRTC instead? Because these are the numbers that regular CDNs serve today, so the numbers that traditional broadcasting serves today. And that's of course not an easy question to answer, because of course there are different WebRTC implementations, and WebRTC as a technology can be seen also a bit more complex than what CDNs typically do. And this is a problem that I actually tried to solve a few years ago. So my PhD at the university was indeed focused on exactly that. So when WebRTC first came to the light, large-scale broadcasting was something that I had in mind. And joking, I always said that it was because at the time I lived close to a pub, and every time I was watching a football match on the streaming, basically the pub would start screaming, and 30 seconds later I would see that somebody scored. And this pissed me really off. And so I said, I want a better streaming solution. I said, well, I'm studying WebRTC now, let's do it with WebRTC. And this was actually one of the key motivators that also pushed me to start working on Janus. So it was one of the use cases that led me to create Janus, which was indeed worked on within the context of my PhD. And the main idea behind Soleil, which basically was an acronym for streaming of large-scale events over internet clouds, was just really a tree-based distribution of WebRTC feeds, where you have WebRTC at the edges. So at the ingestion point you have WebRTC, distribution points you have WebRTC, everything in the middle doesn't need to be WebRTC. It can be plain RTP, because WebRTC is based on that. And there are advantages to doing that, because first of all you don't have the WebRTC overhead. Within your infrastructure you don't need components that need to know anything about WebRTC. They could not even know anything about RTP. They could just handle UDP packets going back and forth. You could take advantage of stuff like multicast or SDNs or whatever. Or maybe if you want to keep at the application level, applications that may know what RTP is for, or maybe do some statistics and stuff like this, but really nothing more than that. And if to do something like this with Janus, basically the idea is that since you have WebRTC on the ingestion point using WIP, it means that you have WebRTC on one side and you have to have RTP out of that so that you can start distributing it. And this is something that in Janus you do with RTP forwarders that our web server does support. And on the distribution part, it means that if you are one of the Janus instances that will distribute this to an audience, it means that you must be able to receive plain RTP packets and turn them into an WebRTC broadcast. And that's something that the streaming plugin is conceived to do. And so that matches nicely with the WIP and web thing that we've seen so far. And from a graphical perspective, it looks a bit like this. So if you imagine a tree-based distribution, where again, we only care about WebRTC on the edges, so ingestion and distribution at the very end, it means that here we can use something like WIP there to ingest, it gets to Janus or any other WebRTC server. I mean, I'm using Janus as an example, but there are other WIP and web implementations out there. So I'm not trying to pimp my own goods, that's what I meant. So you can use WIP there, it gets to Janus, for instance, then it becomes an RTP stream. This RTP stream is something that you can distribute however you want in a tree-based distribution, directly from here to there, but also additional layers. Of course, the wider the tree is, the more you can distribute the flow. That's really just how this tree distribution works. Eventually, it becomes WebRTC again, so that you can distribute it to a very wide audience. And again, using RTP is actually cool because, as I mentioned, for instance, you could use multicast for this, and this is something that the plugins in Janus support out of the box. So if we have WIP here that is WebRTC, sending to the video room plugin, which is our SFU, this SFU could use RTP forwarders to forward this as a plain RTP stream externally, and rather than send to a specific address, we can send to a multicast group. This multicast group is something that those streaming plugins over there can consume, that can subscribe to. So rather than wait for an RTP packet on a UDP socket, a unicast socket, they can just say, pull RTP packets from a multicast group instead, which means that with a single ingestion, multiple streaming plugin instances can all consume from the same thing. You take advantage of your own network if it does support it. You can take advantage of unicast bridges to bridge, for instance, two different server farms that have multicast support. For instance, you have somebody published in I don't know, Detroit, and you want to subscribe in Dublin. You create a unicast channel between those two server farms that have multicast support inside them. That's really the basic idea behind it. And I think this really covers it in a nutshell, but before we finish, just a quick announcement. Some of you may know it already because I've been pestering people for these couple of days already, but we are doing JanusCon again. So JanusCon is our own conference around Janus, but also around WebRTC in general, and it will happen at the end of April in Naples, in beautiful Naples, and specifically in front of this beautiful castle that you see over here. So this is not a fake, the venue is really in front of this, so we are really on top of the sea, it's really cool. And if you go to the website there, you'll find some additional information, including pictures, some testimonials from people that were there for last time, and so on and so forth. So, and now I'm really done and hopefully on time, so let's see if there's any question. Thank you.
So do we have any questions? Just a sec, Roman.
How do you randomize the...
Is it because you want to close?
No. Go to the back of the room.
How do you randomize the connection of the clients to the different front servers? How do you attribute those so that you spread the load across all your infrastructure?
You mean in something like this?
Yeah. How do you decide that this customer, this client will connect to this one or this one, depending on the load of each?
Yeah, this is something that is not cast in stone. I mean, the idea is that you distribute it, and then how you can actually access, how you actually physically distribute users is entirely up to you. So this is really just an idea in principle. So you create a tree-based distribution, and the focus, especially in my PhD thesis, was really just on the internal distribution. Then how you can distribute things, it could be done on a round robin, it could be based on how close you are to the server, it could be done using different things. It could be, some of the servers may be there, may be closer, but the service may not want to use them because they're just there as a backup. So it's entirely implementation specific in this case.
It's not included into Janus.
No. In this case, Janus is actually very stupid in the sense because each of those Janus instances that you see over there know nothing about each other. So each Janus instance is very much an isolated island. So any kind of orchestration that you build is built over the top. So they work with they cooperate with each other without even knowing that they are cooperating with each other. Because again, we are just using RTP as an intermediate technology, and RTP it's an RTP session completely out of context because there's no SIP, there's no WebRTC, there's no RTSP. It's just RTP packets that we are pushing in different directions, and somebody gets them and gets those packets and does something with it.
Excellent. Any? Oh,
Yes, I find it great to see those early networking techniques like multicast being used with WebRTC, because I remember, I'm old enough to remember that in the 90s we were using multicast groups to send and receive RTP packets. We are seeing also others that are doing using Anycast like Cloudflare, for instance. I know that on Janus you have many examples. You have a great demo page where we can try many things. Is it possible to test this multicast, to see it working, this multicast distribution?
Yeah, in general, we don't have a specific demo for that, but just because we don't have buttons that play with this or with that, but it's actually testing multicast, just testing multicast specifically, it's quite easy, especially if you want to do a simple demo of this. It's really basic because the only thing that you have to do is subscribe, you use the regular video room demo and you connect and you publish something. Then just using the console, you use a command, RTP forward command, which is not in the demos as a button, but it's something that is very easy to do. So you say RTP forward media to this multicast group, and then for the streaming plugin, you create a mount point either programmatically or in the configuration file that waits for media on that, subscribes to media on that multicast group, and then you go to the streaming plugin demo and check if you see anything, basically. So that's really as simple as it is, just to prove that you can use multicast as an intermediary, assuming, of course, that your network does support multicast. And then you build around that, basically. That's the main idea, because in this case we have a direct connection between the two. But again, we may, as I've shown before, you could have different levels. This could go through different nodes before it actually gets to at distribution nodes for distribution. So it's entirely up to you, because you may want to use multicast here but not here. So each of those small balls that you see over there, you can handle on your own. That's the basic idea.
cool. If there are no more questions, again, excellent presentation. Thank you so much.
Thank you.